In this video, let's discuss how to solve the Kruskal problem easily. Now, to solve this Kruskal algorithm problem, this will come under the minimum spanning tree. In minimum spanning tree, we will be having two algorithms. The first one is Kruskal algorithm and second one is Prim's algorithm. Prim's algorithm has already been discussed and its video link will be given in description. You can access it. If you see that video, you will solve any problem related to Prim's algorithm. Now let's see how to solve this Kruskal algorithm problem. First they will give a graph and they will say apply the Kruskal algorithm and find the least cost path. Find the least cost path. So it is called as the minimum spanning tree. Now how to find means first step. In the Kruskal algorithm, the step 1 will be remove all the self loop. Remove all self loop and parallel edges. Parallel edges. So what is the first step? See whether there are any self loops, remove them. And if there are parallel edges, remove them. How you must remove means, if there is a parallel edge, remove the most valuable, that is the bigger value you must remove. If you see here between A and B, this A, B, C, D, E, F all will be called as the nodes or vertices. These can be called as nodes or vertex. All collection will be called as vertices. Or and the lines connecting two nodes or the two vertices will be called as the edges. These will be called as the edges. And each edge will be having the different value. It will be called as edge weight. Here between D and E there is a edge and its edge weight is 2, like that. Now if you see between A and B there are two edges. Parallel to each other. So what we must do? We must remove it. How we will remove means between 10 and 5, which is the bigger value? 10 is the bigger value. So what I must remove? Remove bigger value. Why I am removing the bigger value? Because this is the minimum spanning tree. We must use the minimum cost, minimum path. So I will be removing the edge weight with 10. Now there is only single edge, there is no parallel edge. Now we have removed the parallel edge in this graph or the diagram. Now let's remove self loops. How to remove the self loop? If you see here, F node is having one self loop and E node is having one self loop. So what you must do? You must directly delete the self loop. Now there is no self loops and there is no parallel edges in this given graph. We have removed it. Now let's apply the Kruskal algorithm and solve the problem. Step 2 will be solving problem. In step number 2, we will be selecting the source node. Select source node. In examination also, you write this theory also, so that you will get more marks or full marks will be awarded since you are writing the theory and also you are solving the problem. Now, to select the source, any node can be selected as the source node. For reference, let's select F as the source node. Therefore, consider F node as source node. Now we have selected F node as source node. The funda of this Kruskal algorithm is right here. The funda of this Kruskal algorithm is to traverse or travel from one node to another node, from one to another node with least cost. So what we must do? We must travel from one node to another node with the least cost. Now I am starting from F node because F is my source node. If you see, F has the direct connected edge from F to A and F to C. There are only directly connected two edges from F to A and F to C. Among F to A and F to C, if you see the edge weight, which is having the minimum, that is less. 7 is less or 8 is less. 7 is less. So I will be moving from F to A node with the least cost of 7. So I am using the least cost. So it is called as the minimum spanning tree. Now I am at the A node. F node is already traversed. We came from F. Now I came to A. A is also done. From A, I can either go to C or I can either go to B, because only direct connection is for them. It is also there for F, but F is already traversed. So from A I can go to C, or from A I can go to B. If you see the edge weight of both of them, from A to B it is 5, from A to C it is 3. So which is the smallest? From A to C, that is 3. From A to C with the least edge weight or least path cost of 3. Now we are at the C node. C node is traversed. From C I can go to A, but I can't go because A is already traversed, F is also traversed. Now I am left with only B and D. Only B and D because direct connection. Now if you see the edge weight, from C to B it is 6, from C to D it is 3. So which is the smallest value? 3. So I will move from C towards D with the least cost of 3. Now I also traverse D. From D I can go to B or I can go to E. I can't go back to C because C is already traversed. Now from D to B it is 2. From D to E it is 2. So both are also having the minimum cost. So I will be moving from D to B with the least cost of 2. Now I must come to F. Now I must come to E. If you see E, you can come from D to E or from B to E. From D to E you can come, from B to E you can come. You must come with the least cost. So from D to E it is 2, from B to E it is 4. So which path you will choose? From D to E with the least cost of 2. Now we have traversed all the nodes with the least cost. So the final step will be finding the total path cost. Total path cost. So the total path cost will be, add all this. From F to A it was 7. From A to C it was 3. From C to D it was 3. From D to B it was 2. From D to E it was 2. So if you see, 7 plus 3 will be 10. 10 plus 3 is 13. 13 plus 2 is 15. 15 plus 2 is 17. So now we got the least cost path with the 17 as the total path cost value. So first remove all the self loop and the parallel edges and select the source node and follow the procedure which I showed here. So move from each node with the least cost. Find the possible paths and with the least cost you must move to another node. Once all nodes are traversed, find the total path cost. Next, another algorithm is Prim's algorithm in this minimum spanning tree. Its video link is given in description. You can access it. If you have any doubt, please comment below. If you liked the video, please subscribe and support us. Thank you.